Hello everybody and welcome to the next video on loops. So in the previous video I introduced while loops to you. So the point of this video is just to get you more comfortable with those loops by showing you some more examples. So I should say that any of these topics in Python, things like if, lists, while loops, whatever, they take some getting used to. Okay, so it just takes some time and some work with them to become comfortable with them. So after the last video and after this video, you still might not be completely comfortable with while loops, and that's okay. But as we keep working with them, hopefully you become progressively more and more comfortable with them. And so the point of this video is just to show you some more examples of while loops, hopefully helping you get more comfortable with them. In the last video, I showed you some introductory examples of while loops. Today I'll show you some examples of loops that are more sophisticated, that can do more complicated things than the ones from the last video. So we'll start with our first example is calculating a homework average. So recall last time we saw how to let a user create a list called homework scores by putting their scores in one at a time, and that task involved a loop, right? The loop is what let the user keep going, keep giving you scores over and over again. So the question now is, once you have all of those scores, what would you like to do with them? And the most natural thing to do with them, I think, is to compute an average. So computing an average means adding up all of the scores and then dividing by the number of scores, right? That's how you compute an average. So let's think about how a loop might work and what sort of task you need to do here. So to make things concrete, I'm going to have in mind a concrete list of scores. So the list that the user gives you might be way different than this, but having an example like this will make things more concrete for us, I think. So let's just have sort of a playlist here, an example list with 6 scores. And recall that the way that a list is stored in Python, you have your actual items themselves, the 10, 8, 7, 10, 5, 10. Each item has a position. So this 10 is at position 0, this 8 is at position 1, and so on. So if you're going to add up all of these numbers up top, right? You want to add up all of the homework scores. How might you do that? Well, one way to do it is to tell Python, hey, the score at position 0, which is 10, right? The score at position 0, add that to the score at position 1, and then add that to the score at position 2, add that to the score at position 3, and so on. So when you're teaching Python how to add up all these numbers, one way to do it is just to force Python to go through the 6 positions one at a time, start at 0, move to 1, move to 2, and so on. And every step you make like that, moving from 1 to 2, 2 to 3, every step you take, you'll just add up what you see inside the list at that spot. That's the idea here. And you'll keep going until you reach the end of the list. Or, put another way, as long as the list still exists, you should keep going and keep adding. So the reason there's a loop involved in this task is because I said the English word until, or alternatively I said the English phrase as long as. Anytime you find yourself saying that, you're going to need a loop. So until we finish the list, we need to keep adding scores. So here's the idea. We will create a variable that will become the addition of these homework scores. I'm going to call that variable sum of scores. You can call it whatever you want, but this descriptive name seems good. So initially, sum of scores, I'm going to give it a value 0 because it has nothing in it yet. And then what I'm going to do is add the homework score at position 0, which in this case is 10, add that to the sum of scores variable. So if sum of scores is initially 0, then adding this to sum of scores means that sum of scores will have value 10. Then just move on. Right? Click this 0 position up to position 1. So you pick off this next homework score, which is 8, and then move on to the next item, move on to the next item, and so on. That's the idea. So here it is implemented in code. Sum of scores is initially 0. I create this value x. X is going to march through these position values. So initially, x has value 0 because that's the first position. And then notice inside the loop, I increase x by 1 every time. So what does that mean? That just means that x will start at 0, then become 1, then become 2, then become 3, and so on. And that process will continue as long as x is less than the length of the homework scores. there's 6 homework scores, so that length is 6 here, right? So as long as x is less than 6, so as long as x has these values here, 0 through 5, this process will continue. And what is the process? Like, what's happening inside this loop on each pass? Well, sum of scores just gets increased by whatever homework score you're currently looking at right now. So when x is 0, this highlighted block here, right, homework scores bracket x, that is the score 10. Because if x is 0, the 0 is right there, then this homework scores bracket 0 is just the score, or the item, at position 0, which is 10. Then you increase x by 1. So the next pass through the loop, you're looking at homework scores bracket 1, which is 8, and you will increase sum of scores by 8. Okay, so sum of scores was 0 initially, but then you increased it by 10, then you increased it by 8, and on the next pass through of the loop, you'll increase it by 7, because x, right, this position variable clicks up to 2, and then it will click up to 3, and so on. In the end, once this loop is done running, this loop existed to calculate the sum of scores for you. So once the loop is done, your sum of scores now was the addition of all the items in that list, and then to calculate an average, you divide by 6 in this case. Divide by the length of the list, because that's how many homework scores there are. So let me just show you this in the code. So lines 9 through 13, this is a way of grabbing homework scores from a user one at a time. This little code segment here is shorter than what was in the previous video. I've streamlined it a bit. In the previous video, the reason I had code that was a little longer was because I wanted to show you things like the idea of a dummy variable, or show you a break statement, things like that. Here though, this is about as short as you can get if you want to grab information from a user one at a time. So I start with an empty list, then I grab a score from them. As long as the score is 0 or bigger, I'm going to throw that score into the list and then grab another one from them. So it's the same idea as the previous video, it's just a little shorter, streamlined. So as soon as that score becomes negative, this while loop will terminate. So once the while loop at line 11 is done, then I've gotten all my scores from the user. So now Python moves on to line 15, and this now is the code from the slide. So let me just run this. So I'll enter a score. That score is 10. I'm going to start off real good, and then maybe I slip and get a 6 and a 7 or whatever. So let's just say I only have 4 homeworks. So now I'll enter a -1. That -1 will terminate this first while loop that's grabbing information from the user. And as soon as I hit enter, what happens? All of this code starts happening, lines 15 through 19. So Python adds up these 4 scores, 10, 10, 6, 7. And then just prints out the average, 8.25. Right, that's all I told it to print. Okay, so it seems to be working. The average of 10, 10, 6, 7 is 8.25. If you're having trouble picturing what this loop does right here, then I would advise you to do a couple of things. First of all, you can always draw a little table schematic like I've shown you before, like I showed you in the previous video. You can also, in the code itself, ask Python to display things to you. So sum of scores right now is, like, you can just have it on each pass through the loop, print things. So sum of scores right now is, and tell it to print sum of scores if you're confused as to what things are, right? And also print what that x value is if you want. X right now is, and have it print x. You can force it to print things if you want to, just to see what's happening. So let me run this program again. I'm going to enter the same 4 scores, 10, 10, 6, 7. I enter a -1 to terminate the entering of information. And now it outputs a bunch of stuff. So let me just scroll back up. Okay. On the first pass through of the loop, like right here, initially sum of scores was 0, x is 0. Right? So initially, sum of scores is 0, x is 0. Then, after this printing is done, sum of scores gets bumped up, and x gets bumped up. So the next time you print, sum of scores is 10, x right now is 1. And then, sum of scores becomes 20, and x becomes 2. Sum of scores becomes 26, x becomes 3. And then, at the very end, I didn't force it to print again. Right, so at the very last pass through of the loop, sum of scores becomes whatever becomes, this 26 plus 7 becomes 33, and x becomes 4, and things terminate. So maybe be clear if I put these print commands, let me cut them and paste them after like that. Okay, so maybe just run this one more time, and you should be playing with this on your own, you know. So 10, 10, 6, 7, terminate. Okay, so I scroll back up. So now, because I put the printing after it updates things, sum of scores is 10, x right now is 1. And then prints, and then starts to loop over. X is 2, sum of scores is 26, because it incorporated that 6, right? Boom, x is 3, sum of scores right now is 33, x right now is 4, right? And then it's done. Because once x clicks up to 5, it doesn't do anything anymore. Okay, so anyway, all that to say, you can always have like printing commands inside of a loop if you're confused as to what it's doing. But notice 10 to 20 to 26 to 33 is adding things up as it goes. That's what it's supposed to be doing. Okay, so there's an example of a loop to calculate an average for you, although I guess the loop is really calculating the sum first. The average comes in at the very end when you divide by the number of scores. Okay, let's do a couple more examples. So example 2 is going to calculate factorials for you. So let's just recall, if you don't know, or if you do know, we can recall. If you don't know, I'll tell you. If n is a number, then n exclamation mark, or n factorial is what you usually say. It's this number here. The number itself times 1 less than it times 2 less than it. You just keep that descending multiplication going all the way down to 1. So for example, 4 factorial is 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3, so on down. So let's write a program that lets the user enter a whole number, and then we'll print the factorial to them. So, if they enter a 4, we should print 24. If they enter a 5, we should print 120. So let me go to the compiler to do that. So clear all this out. Keep one line maybe. They're going to enter a number for us, so let me keep that. Okay, so they're going to give us a number. Enter their n value. And then what we have to do is calculate a factorial. So what we have to do is create code that does something like this. It takes my number that I currently have and multiplies it by 1 less than that number, then by 2 less than that number, and so on. In Flavor, this is the same kind of problem we just did where we're adding things up. Now we just have to multiply things. Okay, so let's think about how that should work. So let me create something called product. So what I want to do, I want this product to be acting like that sum from the previous example. In the end, I want this product to be the factorial. So maybe I'll do like this. So initially, this factorial number is 1 before I've done anything. And now what I want to do is start smacking this 1 by the n value they enter, then by 1 less than that, 1 less than that, and so on. So let me set up a loop like this. As long as my number is bigger than 0, okay, factorial is going to be itself times number. So on this first pass through the loop, I'm going to take 1 and multiply it by whatever they gave me. And then I'm going to take that number and decrease it by 1. So that then on the next pass through the loop, I'm going to multiply the number I had, the factorial I had, by 1 less than the number. And then in the end, I can just print that. Okay, so let's watch this go. Enter my n value. I'm going to enter a 4. And it prints 24. I'm going to enter a 5. And it prints 120. These values we knew. Okay. So again, if you're confused as to how this loop is working, let me just print what the factorial is at each step. Okay, so initially factorial is 1. I have no information yet. But then the first thing that happens is factorial becomes multiplied by number. And the number gets decreased by 1. So then I multiply factorial by its old value times this new number, and so on. So let me just enter a 5. Look at these values it enters. 5 is the initial value of factorial, right? Because I do 1 times 5 right here. Then number gets decreased by 1. So on the next pass through the loop, I have my old value of factorial, and that gets multiplied by 4. So here's 5 times 4 right here. And the number gets knocked down by 1 again. So then on the next pass through the loop, I have my old value of factorial, which is now 20, times the number, which is now 3. Okay, so in other words, here's 5. Here's 5 times 4. Here's 5 times 4 times 3. Here's 5 times 4 times 3 times 2. Here's 5 times 4 times 3 times 2 times 1. Okay, and then the loop is done, and then it tells me what the factorial is. So you can see that multiplication being created. Let me do one more. Let's do 6. So initially, after you do this first bit of multiplication, factorial becomes 1 times 6. Whoop. 1 times 6. So here's 6. Here's 6 times 5. Here's 6 times 5 times 4. 6 times 5 times 4 times 3. 6 times 5 times 4 times 3 times 2. Here's 6 times 5 times 4 times 3 times 2 times 1. So that the times 1 at the very end doesn't change anything. And then finally, here's what there's that final print command right there. So anyway, there's another loop, right? And this is the kind of thing, if you're not comfortable with loops, you might not see why it is a loop initially. But you can use a loop to just get this multiplication going, descending as you go with that code I had in the compiler. Okay, let me show you one more example. Let's check whether or not a given number is prime. So recall that a positive number n is prime if and only if its divisors are 1 and itself. 5 is prime because its divisors are 1 and 5. But 8 is not prime because 4 is a divisor of 8. Okay, so if you don't remember what a prime number is, there's a definition for you. So let's write a program that lets a user enter a positive whole number, and the program decides if that number is prime or not. Okay, so before we do that, let me just point out that this is kind of a sophisticated task. So let's sketch out a schematic ahead of time. Let's do some pre-planning to decide how we're going to actually code this. So for a prime number program, it's useful to think about how you, without a computer, would check whether or not a number is prime. So if I hand you a number, 132 or whatever, how exactly do you decide if that number is prime or not? And there are many ways of doing it, but let's think about a smaller number, 100 or 15. So the way this is prime is if its only divisors are 1 and 15. So what you can do is just start checking divisors. So start at 2. See if 2 is a divisor of 15. It's not, right? Then go on to 3. See if 3 is a divisor of 15. Oh, it is, right? 3 times 5 is 15. So in other words, what you can do is you can think about starting at 2 and then possibly ending at 14. Just see if any of those numbers are divisors of 15 or not. And if you ever get a single divisor, the number is not prime, right? If you get a single divisor in this range, the number is not prime. So given any number, you can just check if 2 is a divisor, 3 is a divisor, and so on. And if you ever get a divisor hit, you know that the number is not prime. Okay, so let's think about that. Let's think about writing a loop that will just check each individual possible divisor starting at 2 and then going up to wherever it's supposed to end. So I'm going to create a variable called isPrime. I'm going to set it to 1. I'm just giving it a dummy value here. This is a dummy variable, so it doesn't matter right now. And then I'm going to create a variable called x. X is going to be this divisor check. So x is going to start at 2, then become 3, then become 4, and so on. And we're going to check to see if x is ever a divisor of 15. So in this sort of schematic here, x is initially 2, and we're going to work our way up to the number itself. Check if x is a divisor. If x is a divisor, we can stop and then just somehow record that the number given to us wasn't prime, and then check the next x value. So start at 2, then move on to 3, then move on to 4, and so on. Okay, so let me just get that going. While x is less than number, check if x is a divisor of the number. Well, how do you do that? You do it with a command like this. If, when you divide number by x, you get 0. That's what it means to be a divisor. So we've used this before, right? If you take number and divide by x, so for example, if x is 2, right? If you take number and divide by 2 and you get 0 as a remainder, what does that mean? That means that number is a multiple of 2, or it means 2 is a divisor of number, whichever way you want to put it. And if you get a divisor hit, then that number wasn't prime. So I'm going to change the value of the isPrime variable to just something else. It doesn't matter. You just want a record here that you got to hit. And I'll put a break statement in there to stop the loop, because if I get a divisor hit, I don't need to keep looking. Okay, so what's going to happen here? X is going to start at 2. I'm going to check if 2 is a divisor of number. If 2 is a divisor of number, I can stop looking, I can stop the loop, and record that I found something prime. If, however, x is not a divisor, I should up the value of x by 1 and keep looking. So if 2 doesn't work out, I'll go to 3. And then if 3 doesn't work out, I'll go to 4, and so on. So after this loop is over, if the value of is prime is still 1, so I never got a divisor hit, I should print prime. Otherwise, I should print not prime, because otherwise I got a hit. Okay, so let me just run this and let's think about what's going to happen here. I'm going to enter an n value, and that n value is 15. Okay, it prints not prime. Why does it print not prime? Well, right here, number becomes 15, right? X is 2, is prime is 1, whatever. So x now, as long as x is less than 15, and 2 is less than 15, I check and see if 15 is a multiple of 2. And it's not, right? 15 is not a multiple of 2. So I don't do this if statement, I just skip over it, and I increase the value of x by 1. So now x has value 3. Now I check and see if 3 is a divisor of 15. And it is. Therefore, I switch the value of is prime to 0. Right, it used to be 1, now it's 0, and then I break. So then I hop down to this little chunk of code here. If is prime is still 1, which is not, I should print prime. Otherwise, print not prime. Okay, so by contrast, what if I enter a prime number, like say 13? Why does it print prime right here? Well, because if number has value 13, what is this loop going to do? It's going to first check and see if 13 is divisible by 2, and it's not. So I skip over this if statement. Then it's going to check and see if 13 is divisible by 3. It's not, so it skips. 13 divisible by 4. It's not, so it skips. 13 divisible by 5, and so on, right? It checks all the way up to 12. 13 is not divisible by 12. So by the time you reach line 18 right here, once you escape that while loop, you have never changed the value of this is prime variable. Right? It was 1 up top. It was 1 initially. And then it never changed, right? You never got to change it to 0. So all I'm saying here is prime, if it's still 1 at the end of this loop, what does that mean? That means you never got a divisor hit. So if is prime is still 1, that means that your number is prime. Otherwise, your number is not prime. Okay, so there are 3 more sophisticated examples of loops. Adding all the elements of a list so that you can compute an average if you want to, calculating factorial of a number, checking whether or not a number is prime. All of those things involve loops, and they're fairly sophisticated. So I guess I should say there's only like 12 lines of code right here. You know, this is a short program in terms of the amount of typing, but the logic here is fairly sophisticated, you know. So when I say more sophisticated examples of loops, I don't necessarily mean more code. I just mean the logic is more sophisticated. Okay, so hopefully these examples are somewhat clear to you, and hopefully you've had a chance to play around with them some. Any questions you have, please let me know.